Hello viewers, welcome again to our channel for another round of tutorial on basic concepts of 3D modeling in FreeCAD. Today we shall discuss about axes and planes in 3D geometry. This is again a very important topic as we must have a clear conception on different axes and planes on which we make our initial 2D sketch before we convert it to a 3D object. We know that in 3D geometry, we are to work with three axes, namely x-axis, y-axis, and z-axis. With these three axes, we can have combination of three planes, namely xy plane, xz plane, and yz plane. Xy plane, as the name suggests, consists of x-axis and y-axis. Similarly, xz plane consists of x-axis and z-axis. And lastly, yz plane consists of y-axis and z-axis. We can possibly visualize these three planes when we look at the isometric view of this 3D block. We have given three different colors for three planes, namely xy plane, xz plane, and yz plane for our better understanding. As we have already seen in our earlier tutorials, that in FreeCAD we have to first select the plane on which we intend to make our sketch. Now let us select xy plane and try to make a simple sketch for a hexagon. For doing that, we have to select this tool by clicking it and bring the cursor to the center and drag it vertically. So this is our hexagon. Let us now extrude it by clicking the pad button to convert the sketch into a typical 3D hexagonal pad. Let us put some color to make it a bit lively. Okay. So this is our hexagonal pad. Now since we have opted to draw the hexagonal pad on xy plane, this is how it would look. We have three different views here: top view, front view, and side view, right hand side view. Now this time let us consider that the same hexagonal pad is now drawn on xz plane. That means the plane consisting of x-axis and z-axis. X-axis is a horizontal line and z-axis is a vertical line, vertical axis. So the plane consisting x and z-axis is a vertical plane. Now if we draw the same hexagonal pad on this xz vertical plane, our views this time will be different. Top view, front view, and right hand side view would be different than what we had just seen in case of xy plane. The top view this time would be something similar to the front view of the hexagonal pad drawn on xy plane, which we had just seen. Similarly, this time the front view would be similar to the top view of the hexagonal pad when it was drawn on xy plane. Of course, the right hand side view this time is different because this time the pad is lying on a vertical plane, and when we are looking from the side of it, right hand side of it, it would be a vertical rectangle. a rectangle placed vertically, as you can see from the right hand side view. Similarly, when we draw the hexagonal pad now on YZ plane, which is again a vertical plane consisting of Y axis and Z axis, the corresponding three views, that is top view, side view and the front view of the hexagonal pad, would be something like this, as we can see here in this slide. And finally, this is the overview of the hexagonal pad drawn on three different planes, as we have just seen in our previous slides. In today's tutorial, we will build up this 3D model. These are some of the ruling dimensions of the body. Friends, we need to remember that each time before starting any of our new assignments, we have to look at the model very carefully and finalize a strategy for sequence of our intended operations. This will make our life easier and also save a lot of time. Here, as you can see, this model consists of three distinct parts. This is the first part, this is the second part, and this is the third part. This is the fourth part, which is nothing but the mirror image of the third part. And finally, we will carry out this pocket operation for making the hole on this second part. Now, our strategy today would be to build up the first part first. Our second job would be to build up the second part onto the first part. Our third job would be to join the first part and the second part with the triangular rib. Our fourth job would be to create a mirror image of the rib on the other side of the second part. And finally, we'll make a hole in the second part to complete our today's assignment. Now, from this isometric view, we can see that we need to draw the cross section of this first part on XZ plane and then extrude it along Y axis and assign a suitable dimension of 160 mm for the desired length of the first part to transform the 2D sketch into a 3D body. So let's go for it. To start our today's assignment, we select XZ plane and we click and select polyline tool to draw our sketch. Go upward along Y axis, then click once and draw the horizontal line, and again click and make a vertical line and continue the process till we come back to our start point and complete the sketch. This is just a tentative sketch of the profile. We now select all similar points on the horizontal lines on both sides of y-axis. Click and select y-axis and click the symmetry tool to make the sketch symmetric against y-axis. Then we assign some of the ruling dimensions as per our drawing. We then close it. We click Pad tool to convert the 2D sketch into a 3D body. Now let's type the figure 160 to make the first part 160 mm long. Our first part is ready. Our next job would be to build up the second part on the top face of the first part. For that, we have to draw the sketch for the second part on this face of the first part, that is on YZ plane. So let us select the face by clicking on it and then click the tool for creating a new sketch. We are now ready with the workplace. For creating the sketch, we select the polyline tool again and start drawing the profile. Just keep pressing M key repeatedly till you get onto the tool and draw the arc, and then again change over for drawing a free line and come back to the start point and finish the sketch. This is a free sketch. We need to connect this line to this edge. For that, we click on to this tool for linking an edge to an external geometry and then click the edge. Now click the edge and this point to select them, and then click the tool for fixing a point onto an object. So the edge is now linked with the sketch for second part. We now need to assign some ruling dimensions to the sketch as per the drawing. The vertical arm is 40 mm. Dia of the arc is 50 mm. The distance between these 2 points is 55 mm. Since the total length of the first part is 160 mm. We now make both the vertical lines equal. Now the sketch is fully constrained. We click the close button to close it. We now extrude it along x-axis by clicking the pad tool. And the extrusion will be equal to the width of the first part, that is 76 mm. We type 76 and also select reversed option here to ensure that these two faces match each other. We click OK. We get our second part duly resting on the top of the top face of the first part. Then we move on to build up the third part, which is a triangular rib connecting the first and the second part. The sketch of this part also to be made on YZ plane and then extrude it along x-axis. but the rib will have to be placed in the middle of the second part. And for doing that, we will use the tool for datum plane. In FreeCAD, datum plane will give you a great deal of flexibility to draw a sketch almost at any location attached to the body and then extrude it to have a 3D object. Let's go for it. We have to first select a face to which the datum plane would be attached. We select this face by clicking onto it. Then we click the tool for datum plane. So here is our datum plane. We have to now place it in the middle of the second part along its length. Now let us come to option Z for attachment offset value and type -76/2. As we know, the length of the second part is 76 mm. A positive value here would place it further away from the edge. Click OK. Now click Create a New Sketch button. All the relevant planes are displayed. We select datum plane and click OK. So now we are ready with our plane and working area for making the sketch. We again select the polyline tool and draw the sketch for the triangle. Now we have to connect this line tangentially to this arc. For that, we first click this tool to create an edge to an external geometry and then click the arc. Select this line and the arc and then click the tool for tangent constraint. So this line is now a tangent to this arc. Again click Create an Edge tool and click the edge. Now we have to connect both these 2 points. We select these 2 points and click the coincident tool. Both the points meet at one point. Let's make this line perfectly vertical. Let us stretch the line and connect it to the arc tangentially. We are now ready with the sketch. We now close it and click the pad tool to extrude it. Let us click symmetric option to place it right in the center. Click OK. We now delete the datum plane. So our third part is also ready. Our next job is to make the fourth part of our project, which is basically the mirror image of the third part or the triangular rib. For this, we will use another datum plane and use it as a mirror along the length of the second part to obtain a mirror image of the rib on the other side of it. This time we select this face on XZ plane for necessary attachment of the datum plane. Then we click the tool for datum plane. We now have to place it in the center along the length of the first part of the body, which is 160 mm long. Now let us come to option Z for attachment offset value and type -160 by 2. Click OK. Now we click the rib, then choose the plane against which we want the mirror image. We choose the datum plane. Click Mirror Image tool in the toolbar. Select Pad 02. Click OK. Click Select Reference in the drop-down menu and then click the datum plane, which is our reference plane here. Click OK. The moment we confirm the datum plane as the mirror image is generated. Click the datum plane to select it and delete it from Edit menu. Click Yes. At the end, we will make a hole on the body of the second part as per the model before we close our assignment. For that, we click the desired plane on which we want to make the hole. Click the tool to create a new sketch again. Then we click the tool for circle and draw a circle. We fix the dia of the hole as 28 mm. This circle can be placed anywhere on the selected plane or face. We have to now make the center of the hole and center of the arc coincident to each other. For that, we have to first find out the center of the arc. We click the tool for creating an edge to an external geometry and then click the arc. We get the center of the arc. Now we click to select both the center points of the circle and the arc and then click Coincident tool from the toolbar. Both the center points are now coincident to each other. The sketch of the circle is now fully constrained. We close it. We now click the pocket tool. Hole is made on the face. To make the hole through and through, we select this option from the drop-down menu. We get a clear hole and our job is complete. We click OK. With this, we come to the end of our today's tutorial. In case you have liked it, please hit the like button and share it with others. And lastly, please do not forget to subscribe my channel, which would enable you watch more informative videos in future. Thank you for watching the video.